Hey everybody, hope you're all doing good. I've got a pretty funny video for you today, which all started with me going to the dollar store here, ouch, in Canada, and picking up one of these because, I like to buy myself little goofy things, especially when they're only a couple dollars to have some fun with. So this is the Tech One USB powered voice activated light, which basically plugs into a USB port on your computer and then gives you light. So I'll show you how it works. There you go. You plug it in, you get light. It's voice activated, so you can say turn off, turn on, which is the most important thing for this video, turn on. And then we can also say red color, green color, blue color, white color, which is all three of the LEDs, that's important, white color. And then the one cool feature of it is go to bed, which causes it to dim and then shut off. Turn on. So that's basically how that works. So when I bought this, I thought, this is cool. I like it. It was only $2.50 Canadian. So it was a pretty good price. So when I got this, I thought, well, can we just hook up a computer power switch to the back of this here and use it to turn off and on a computer? Well, the answer is no. But now the answer is yes, because I have made this incredibly cursed voice-activated switch for the computer, and it works. I'm going to show you how I did this. But before I get into it, I'm going to show you, let me put my light here. You can see the blue wire goes into, that's the header from this. This is an XW6200 Compact, HP, whatever you want to call it. That's the actual header there, disconnected. And here's our blue wire plugged into the motherboard. So this is real. All my videos are real. I don't fake anything. I think it's stupid and a waste of time. So this was started as just what I thought was going to be put two wires in and have it work, which didn't work. So then I had to take a crash course in electrical engineering, which I kind of know a little bit about, but I'm definitely not an electrical engineer. So the issues that I had with this was that it was not working. So then I tried hooking up I had to get a relay. I found after this that it wasn't working. I had to get some sort of a mechanical switch. So hence I found these on an old modem card that I had, which are a Fujikawa, I know it's a Takashimawa. What do you call this thing here? The switch, the relay switch. So this one, if you look at it close, gonna be kind of wiggly with this. I'm just free holding the camera here. But this is actually a 5-volt relay. So I said, oh, perfect. It's the only one that I had. It was off an old ISA modem card that I had. So I thought, we'll use this. This should output 5 volts because it's USB. It's running off 5-volt power. But it wasn't enough to trigger the clicker, which I tested the clicker just with a 5-volt. And it worked fine, but unfortunately, this thing does not output 5-volt with multimeter. With my multimeter, I was only getting about 1.5 volts, so I thought, well, I'm going to have to boost the power going to this, but I don't know how. So what I did is I got these two coin cell batteries, wired them in series with this. I have a diagram here. I'll show you in a second how I did it. So I wired of the positive going into these batteries to boost it. They're 3 volts each, so both of them together is going to be 6 volts. And then I have this capacitor here, which I figured would, well, before I get to that, the issue I was having was that I was having enough voltage now to power the clicker. The only thing is that it wasn't, I can show you the diagram for the clicker here, the relay, but the issue with the relay is that it needs a minimum of 3.5 volts to turn on. However, to shut off, it needs a minimum of 0.03 volts. So it basically needs no voltage going back into it. And the problem with this stupid thing is that it gives too much voltage, and it wasn't actually shutting down all the way with the battery hooked up to it to boost the voltage of this thing. This will shut off and go to 0. No voltage coming out of that when it's off. But these batteries hooking into it, even with the capacitor by itself, were providing a voltage for this switch that I couldn't get around. So I thought, well, how about I use a capacitor capacitor charges up and then puts out the voltage, and then when you shut it off, it'll not have enough. So I said, okay, that actually works. So I was able to use the 1.5 volt from the USB, the 6 volt from the battery. So my total volt is about 7.5. This is a 6.3 capacitor. So it was working great. And I was using my multimeter to check it. My 2 pins of my multimeter on there, I had it set for 6 volts. It's actually a battery tester I was using. So when I would say turn on, turn off, I could see the voltage increasing and it was working. Now, when I unplugged or removed my multimeter leads from the capacitor, it wouldn't work. So I actually had to put this little 510 ohm resistor on it here to trigger that, and then get everything wired up, and then it works. So here's my diagram. Let me set this down here. Here's my diagram. My God, very professional diagram. So you'll see, here's our USB power, it goes over, we have 1.5 volt coming out, it's going in, our positive of our USB is going into the, I need some sort of a proper sticker to point. Our positive line from our USB is going into the negative terminal of our two batteries stacked together. We're running 1.5 volt, goes into their 6 volt, we're running about 7.5. That goes into our positive terminal on our capacitor here, 6.3 volt capacitor, running through the resistor. I don't even know, it's just got to connect. I guess there needs to be some sort of impedance on there for it to trigger. I don't really know, I'm not an engineer. Our resistor's in the middle of it there. Our line is now going in from the negative out, line of the capacitor, running around into our one side of our switch here, of our relay. And then the other side of the relay is running into the negative terminal of the USB talkie dongle there. And then our switch for our actual computer, one side of the computer switch is going to the ground, so the bottom pin on that one, and then the other side of the computer switch is going into the NO, the normally open pin on there, because it's usually open. And then when this thing works, it gets power, it closes, our relay will shut, that will give the signal. Let's actually get the power button here to show you. So that's probably all gibberish, and people who are electrical engineers, if you're watching this, I don't know why you make shit so complicated, but I'm not an electrical engineer, so I'm talking to you in Dominic jargon. So how this works is that when we say it's unplugged right now, another thing with this is that we need 5 volt power going to it, which will work fine on a board, a computer that has 5 volt standby power. But this old HP, this is before they invented that. So what I'm using when I plug this in is that I'm actually going to plug it into this tower with 5 volt power, which this will actually work when it's shut off because that tower has 5 volt. That's a X99 Asus board in there. But this one does not. So you do need 5 volt power going to it. But it will work when the computer shut off. You do need a tower with 5 volt power if you do attempt to build this. So when you talk to this thing, as you saw a few minutes earlier there, when you say turn on, but basically what's that going to do is that's going to power it. So with a computer switch, as you probably know, when you turn on a computer, all you do is go, and then the computer's on. So that is really closed and then open again. So when we talk to our beautiful switch here, we say turn on, it's down, but then we have to say turn off, and it will open it again. If we just say turn on, the computer will turn on, it'll boot up for a second, and then it will shut down because it thinks that we are pressing the switch down. So you see in a second here when I do this, I'm going to say to it, turn on, it's going to turn on, and I'm going to say turn off, and then our computer will boot up properly. So I had my stool here because I was going to do this, but I want to show you how legit this is. So what I'm going to do is I'm actually going to, let's plug this in here first, and I'll show you the switch. The computer is actually, there we go, that's got power. The computer, the mains is actually unplugged from this now. So I'm going to go close, and we're going to talk to it, and then you should hear it work. So turn on, turn off, turn on. Okay, apparently it's not actually working for some strange reason. It should. All right, sorry about that. So we're back now. The issue is that the resistor there had actually come loose because I built this entire thing, as horrible as it is, without a soldering iron because I broke my soldering iron. So right now I'm going to tell the machine to, and I have to watch what I say because it is kind of finicky and it will shut off if you're on the phone or doing something and you say those words. It will do it. So I'm going to try to phrase it as carefully as I can without it doing its thing. So remember, as I said earlier, I have to tell it go, and then don't go. So here we go. You can see it's not running right now. There's nothing on my screen. Let's shut you off. So I'm going to tell it, here we go. Turn on, and then turn off, because I had to close the switch. So now you'll see it work. I'm not touching anything. I'm here. I'm going to try to talk to it from a distance, because the whole purpose of this would be to have the computer to turn on, you know, when you're not near it, to touch it. So let's see if I can get it to go. Turn off. Turn off. Turn off. It's turn off. Turn off. No, you can't shut it down now. You're too far into it, boss. I don't know if it actually lets you. It should. Turn off. Turn on? Oh, that's stupid ass me. Oh shit. Okay. Turn off. Okay. Now, okay. Let's try that again. Hands free. From far. I just got out of the shower and I gotta turn on. Aha. Turn off. I heard it click. Okay. That's my stupid fault. I forget that that we we have to cycle it from far away to do it. So let's it's running now. I can see it. There we go. Yeah, we got it again. But what I'm gonna let it do? Let's go a little farther. I'm gonna yell at it and see if I can get it to go. Which I have to say on. I forgot. Turn on. Ah, it worked. Turn off. And you can hear the relay click. Okay, let's go even farther away now. Turn on. That worked. Turn off. I think I got it to the off there. I'm not too sure. Well, it's still running, so I guess so. So let's take a look at this now. This is, I don't know. This has got to be the funniest thing that I built, man. I tell you, this thing is, I don't know. And you know what the funny thing is that I've actually wanted one of these for a long time, but nobody has really built one of these before. You can see them and they're like, oh, use Arduino, oh, use Google Nest. Like, no. This is built with true American, I'm not even American, true American parts and real resistor and Chinese USB stick. And, oh yeah, there's our Windows is angry, so I'm gonna hit enter to go into Windows XP. And then what I'm gonna do is I'm gonna walk all the way across my basement, which is pretty big, not to brag, and see if I can get it to shut down from all the way across the basement. And like I say, this video is legit. I'm not making anything up here. This is all the real deal. And I actually have a speaker, but I don't have the sound driver installed, so we won't actually be able to hear it. No. Gonna let that boot into Windows XP there, and then we'll walk all the way across the basement and see if I can get it to shut down by yelling at it. So now we're on our desktop here now. Let me go all the way back, not trip over anything. Let's go all the way back here. Let's go all the way back. Now I'm a good distance away, and we should see the blue screen of, okay, I literally can't go back anymore. I'm gonna say, turn on! I don't think it can hear me from here. Oh, it worked! It worked! It actually shut down from all the way across the basement, and it should turn back on because the switch is technically still being pressed, so by the time I walk over here, it'll probably, well, maybe not. You think it would because it's shut down. Turn off. Turn on. And we'll boot it back up again. And then turn off. I don't know if you can hear it click on the video, but it's doing its thing. I don't know. That's hilarious. That works all the way. Like you can see for like it's a good distance away that it heard that. That's pretty funny. This thing's pretty basic. It's basically an I/O chip, a microphone, and my wires running into it. Turn on. Turn off. Okay, that's hilarious. I love it. But anyway, that's going to be the video. Again, that's how you build this thing. That's how I built it. The real kick in the ribs is that you can bypass all of this bullshit and just get one of these that is a 1.5. Did you feel like focusing? There's a 1.5 volt of these. They make these from 1.5 volt all the way up to 12 or 15 volt, I think, this brand of resistor. And this is old. This was off an old modem. But yeah, with a 1.5 volt, you'd be able to turn on. Okay, I guess not. Turn on. Turn off. You'd be able to do that without any of this screwery around in here, because it's just this puts out about 1.5 volt, and that should be enough to trigger one of these. But I didn't have it. This cost me $2.50 plus about an afternoon of my sanity to have this. And yeah, there we go. One more time. Turn on. God damn it. Turn on. Turn off. And that's that. Hope you all enjoyed the video. I enjoyed building this. Any questions, feel free to ask in the comments, and hope you guys have a great day. Bye for now.